Okay, this lesson is going to be on the unit circle. The unit circle is a subject that causes many students much grief in precalculus. So I'm here to simplify this subject for you once and for all because it turns out there's a mega trick that, well, it's not really a trick, there's just if I teach it the right way, you'll have an understanding that'll make it so you can solve every single problem related to the unit circle quite easily, as long as you just understand how it's set up. So that's what we're going to go over today. We're going to demystify the unit circle forever. Okay, so what I have drawn here is a standard XY axis that you're used to. And on that XY axis, I've drawn a circle in blue right on the center. And I've blown it up a little bit, but we're going to say that this circle has radius 1. Okay, so the radius of this circle is 1. Now, I've drawn this triangle here. It's a right triangle. It has a 90-degree angle. All angles on the unit circle will be measured from the x-axis. So a line that goes straight down the x-axis, that's like our 0 line. So we're calling the positive x-axis here, that is what we're calling 0 angle. And then the angle is measured as it goes up from there. Okay? Now, I'm going to assume that you're okay with sohcahtoa. That's your sine, cosine, and tangent equations from a previous class. And if you have that, it's going to make this a lot easier. So here's what we're going to do. The right triangle that I've drawn, we're going to apply the sine function. So I'm assuming that you know the s.o.h of sohcahtoa says that the sine of the angle theta is equal to the length of the opposite side of the triangle divided by the length of its hypotenuse. Okay, so we're going to apply this equation to the unit circle we've drawn here. Now, in this case, the opposite side of the triangle would be this guy, right? That's the opposite side of our right triangle. Okay. And then the angle we've already drawn here, this is the angle theta. Okay, so let's use our sine equation to put that all together. So we get the sine of the angle theta is the length of the opposite side, which I'm still just going to call opposite, divided by the length of the hypotenuse. Well, what is the length of the hypotenuse in the case of the unit circle? Give you a hint, it's in the name. It's unit circle because the hypotenuse has a length 1. Okay, you'll notice the length of the opposite side divided by 1 is just the length of the opposite side. So we find that on the unit circle, in the case of the unit circle, the sine of theta is equal to the length of the opposite side. So remember, sine is just a function. What's a function? A number goes in, an angle for theta, some number between -1 and 1 pops out. Okay? So the number that pops out in this case will be the length of the opposite side. So on the unit circle, the length of this side is equivalent to the sine of theta. Cool? Similarly, if we do a similar argument with the cosine, the s.o.h, I'll assume that you know that the cosine of theta is equal to the length of the adjacent side of the right triangle divided by its hypotenuse. Okay? We're talking about the same triangle, so the hypotenuse is still 1. And we find that in the case of the unit circle, that the cosine theta is equal to the length of the adjacent side of the triangle. In other words, let's get another color here. Let's see, we'll go green. The adjacent side of this right triangle, which I'm doing in green here, well, in the case of the unit circle, that will be equal to the cosine of theta. Okay, so the big takeaway here is that the opposite side of the triangle in purple, if it's a unit circle, if the hypotenuse is 1, is the same thing as the sine of theta. The adjacent side of the right triangle is the same thing as the cosine of theta. If you get that fact that on the unit circle, the opposite side of the triangle is always equal to the sine of theta, and the adjacent side is always equal to the cosine of theta, it's going to make your life much easier, and that's the fact that will help us solve any problem related to the unit circle. Okay, so that being said, you'll notice that, let's look at the coordinates of this point right here. See this point? what are the x and y coordinates of this point? Well, you'll notice that the green here is the exact same thing as the x coordinate of that point. Totally the same thing. In other words, the x coordinate of any point on the unit circle is equal to the adjacent side of the triangle, which is cosine theta. Similarly, you'll notice that the opposite side of the triangle, in purple, well, that's equivalent to the y coordinate of that point. And what is the y coordinate? It's equal to the sine of theta. That's the argument we just made. So, on the unit circle, the x coordinate of any point on the circle is always equivalent to the cosine of theta, and the y coordinate is always equivalent to the sine of theta. Okay? How can we use this? Well, let's go down a little bit. And I'm going to redraw my circle a little quicker this time. How can we use this to solve a problem in pre-calc? A typical problem would ask, say, what's the sine and cosine of 150 degrees? And we're not going to use our calculator. Okay, so the first thing you always want to do is draw the triangle. Okay, so we're going to call this quadrant 1. That's 0 to 90 degrees. This will be quadrant 2. That's 90 to 180 degrees. This will be quadrant 3, which is 180 to 270 degrees. And this will be quadrant 4, which is 270 degrees to 360. Okay, so our angle given here is 150 degrees. So what quadrant will that be in? Hopefully you answered 2. In other words, our right triangle will be drawn in quadrant 2. Now, when drawing your right triangles, you're always going to drop a line straight down to the x-axis. It's always going to make that 90-degree angle with the x-axis, not the y-axis. Okay? Now, 150 degrees is this angle. Okay, but what we want to do now is find what's called the reference angle. And the reference angle is always the closest angle to the x-axis. So the closest angle, it's going to be our triangle, right, to the x-axis is now this guy here. I'll use phi so we don't get it confused. That's what's called our reference angle, okay? And that's the angle we're going to work with. So if it's 180 degrees all the way from here to here, can you tell me what our reference angle is? Well, this guy is 150, and it's 180 all the way halfway around, so that means that our reference angle must be 30. And as before, our hypotenuse is 1. And I'm going to assume that you recall the 30, 60, 90 triangle from a previous class. If not, we can talk about that later. But given that the, just as a quick reminder, I'll put that down here. We'll do a little 30, 60, 90. The deal with those is what we call a special triangle. If the short side across from the 30-degree angle had length x, then the other leg would have length root 3x, and the hypotenuse would be 2x. Okay, but in our case, our particular case, we're on a unit circle. That's the name of this video. The hypotenuse is 1. In other words, 2x equals 1, or if we divide both sides by 2, we get that x equals 1/2. Okay, so that's this side of the triangle. That's 1/2. And if x is 1/2, that means that this guy will become root 3 times 1/2. Or, make that a fraction, we get root 3 over 2. In other words, the adjacent side of our right triangle is root 3 over 2. Eventually, you're going to memorize the special triangle angles. But for now, we see, and in fact, I'm going to call this a negative root 3 over 2 because you'll notice that the adjacent side of the triangle is in negative x territory. Okay, see how that's in the negative x side of things? Whereas the opposite end of the triangle, or sine theta, is in positive y territory. So we're going to keep that positive. Okay, so remember, the main takeaway from this whole lesson is that the opposite side of the right triangle is always equivalent to the sine of theta, and the adjacent side of the triangle is always equivalent to the cosine of theta. Thus, we can see that the sine of 150, remember the sine is the same as the opposite side of the triangle, this guy. And what is the length of the opposite side of the triangle? The answer is 1/2. So the sine of 150 degrees is positive 1/2. Again, positive because we are in positive y territory. Oh, excuse me. Let's try that again. Let me make that smaller. Okay. Dang it. Try one more time. Sorry, guys. Let's make that even smaller. How about like that one? The sine of 150 is 1/2. There we go. Okay. The cosine of 150 degrees, again, remember, the adjacent side of the triangle is always equal to the cosine of theta. Same thing. That's the whole point of the lesson. We can see that's equal to negative √3/2. Again, it's your job to determine whether it should be negative or positive, and we do that by drawing the triangle and seeing what part of the unit circle it's in. Because the adjacent side is in negative x territory, that means it's going to be a negative √3/2. Okay, and there you go. So again, the main takeaway from this lesson is that when you draw your right triangle, your reference triangle, the opposite side of that triangle is always equivalent to the sine of theta, and the adjacent side is always equal to the cosine of theta. Okay, so I hope that helps you out. You can reach us at alexandertutoring.com if you have any more questions, or you can call myself directly at 415-312-4720, and I would be happy to solve all your math problems. Okay, take care.